When we start our journey here in this discussion, we are going to first look at fatty acids. A fatty acid, all it is, and do I have a picture? I'm looking to see if I have a picture. I'll just show you a picture. All right, there's the words. A hydrocarbon chain found in lipids. You're like, what in the heck? Well, hydro means hydrogen. I'm just going to put shorthand for hydrogen and carbon. So it's just a chain of those two molecules, and that's it. Let me click here. Will that work? Yes, fantastic. This is a hydrocarbon chain. Holy smokes, all it is carbon and hydrogen, right? You love chemistry. Who doesn't love chemistry? Good God. Here you can see we have some, again, it's a O's. Oh, okay. So, it can be different. You can have a double bond there. Multiple double bonds, a whole bunch of double bonds. Okay. But when it comes to a fatty acid, all that is just a chain of what we call hydrocarbons, carbon molecules and hydrogen molecules. Okay. You can see we have an omega end and we have an acid end. Okay, let me go back to where we started. Okay, here's our omega end. And it's just the end of the chain containing the methyl group. Okay. Omega-3, omega-6, omega-9. We based those names based on coming from the methyl end of the hydrocarbon chain. That's where that moniker comes in. The other end is an acidic end. It's called a carboxylic acid. Okay. Carboxyl group, carboxylic acid. Right. This is the other end of the spectrum. I think there are some nomenclature models. For here in the United States, we use omega. Okay? We use the omega. That's what our defining number is. That's where we kind of say, okay, omega-3 is the third carbon from the omega end. That's all that means. Okay. There are some other nomenclatures that do it from the carboxylic end, but that's not very common. So I think maybe this version of the textbook has it. I think the next version doesn't have it in there. So I can't remember. I get all these versions, swapped in my head. But the omega end is the most important end for you to know because that's how we name these fatty acids in our diets. All right. Fatty acids can be very simple, very, very, very short. 2 to 4 carbons in length. That's pretty damn short. They can be extremely long, anywhere from 14 to 24 carbons. Those are really long. And then we have something in the middle, medium. Okay. When someone's saying, oh, I'm consuming more medium chain fatty acids, this is what they're talking about. They don't know what the hell that means, but it's anywhere between 6 to 12 carbons in length. All right. What does that mean from a body utilization standpoint? Long chain fatty acids require a heck of a lot more work to digest. And when we get into digestion, we'll make reference to a little bit of that. Does that mean it's not going to have a greater effect on body levels of lipids? No. It's going to go a different route. Short chain, medium chain fatty acids get into the blood very fast. And we'll make reference to that when we get into digestion absorption. But this is all what defines short chain fatty acids, medium chain fatty acids, long chain fatty acids. Excuse me. Okay. Again, fatty acids are going to be defined by the number of carbon atoms that exist. Right? So if it has 20, it's a very long chain fatty acid. Right? We also name these things according to if there's any double bonds. And you can see right here, This one has a name. There's no double bonds here. This is a saturated fat. All that means is every bond that is available to bind to carbon is saturated, is bound with a hydrogen atom. You can kind of see if I have a double bond, I remove some hydrogens, right? And you can see I get different names: oleic acid, linoleic acid, alpha linolenic acid. So I get different names. So if there's double bonds, I get different names, because I've removed some of the hydrogens within the structure of the fatty acid. It's also going to do some fantastic things to it, which make unsaturated fats a little bit better for you. Okay. So short chain, medium chain, long chain, 2 to 4, 6 to 12, 14 to 24. That's what those mean. Okay. They get used a lot of bit. They get thrown around quite a bit. They get used quite a bit. That's what that means. Okay. Excuse me. Sorry, guys. All right. So our first fatty acid chain we have is a saturated fatty acid. Okay. I just shorthanded FSA. SFA. Okay. Each carbon bound with a hydrogen atom. Okay. So every carbon in this chain here is going to be bound with hydrogen. R and R. Okay. So every open bond here that carbon has with it, and remember, carbon can bind with 4 to make 4 bonds, right? Every bond it can love to have binds with hydrogen. This forms a very straight, very rigid chain. Okay. I can pack a number of these together here, right? If I was to draw these as a line, okay, I can pack these in here. They're very straight. They're very rigid. They don't wiggle. They don't move. So I can pack a whole buttload of these saturated fatty acids together. These are your animal fats. Okay, these things are solid at room temperature. Okay, animal fats, lard, very high in saturated fats. Okay, these things provide a buttload of units of energy, okay, especially if they're long chain. Right? Straight, rigid, tightly packed together, so I can get a whole lot of them in there. And because I can get a whole lot of them in there, I can get these things to solidify at room temperature. Fats, animal fats, lard being an animal fat, all of these things are very, very, very high in saturated fats. Butter can be as well. Okay. Just depends on the type of butter you have, obviously. Unsaturated fat is the opposite end of the spectrum. Okay. With an unsaturated fat, all you got to remember is that it has 1 or more double bonds. That's it. Okay. When we have a double bond in there, it obviously takes away from 2 hydrogen molecules. Okay. So there's less hydrogens, which is ultimately going to have an effect on how much energy we can get out of these things. Ouch. Sorry, that's my knee. But the biggest thing about these, right? The biggest thing from a structural standpoint about these things, when comparing them to a saturated, with that double bond, is that it forms a kink, right? And this is just the chemistry that is a carbon-carbon double bond. Okay? If you want to know why in the hell that happens, go take some chem. Okay. And you'll look at it there and you discuss it there. So this creates a kink. So if I was to draw that, because my drawing's fantastic. Okay. Oops. Okay. So it creates a kink. Okay. I can't draw to save my dang life. Okay. Creates a little kink. When I create a kink, okay, again, with a saturated fat, right? I can stick all these together. I can put all these together. But if I create kinks, okay, now they're not, I can't do it. Now, if I create a kink, there we go. Okay. Now they don't stand. Now they're not packed tightly together. Now they have a kink because there's a double bond there. All right. So this opens it up. Okay. Now these things can wiggle a little bit. And if I remember here at the very end, I'll try to pull up a little video just so you can visualize that. Okay? But this creates a kink. With that kink, they move. They can't pack tightly together. So if they can't pack in tightly together, these are always going to be liquid at room temperature. These are your, as you can kind of see up there, olive, peanut butter, avocados, yum. Give me some walnuts, yum. Sunflower. I mean, these are not animal, right? These are all plants. So your plant-based oils, they are going to be the unsaturated fatty acids. As you can kind of see, you can have a mono unsaturated fatty acid, MUFA. I just love saying that word. Mono means one, right? So this has one double bond. Poly means many. Well, more than one is many in this word, in this nomenclature. So this has two or more double bonds, and these are your polyunsaturated fatty acids, your PUFAs. And who just doesn't love saying PUFAs? Who doesn't love chemistry? I love chemistry. Got a chem minor, for God's sakes. I love chemistry. I don't like PChem. I didn't take PChem. I wasn't that psychotic. So these are your two types of fatty acids, two basic types. One tightly packed together, very rigid, solid at room temperature, saturated fats. Every carbon is smacked with a hydrogen atom. On the opposite end of the spectrum is your unsaturated fatty acids. Okay? They have kinks, they have double bonds. So they're going to be more liquid at room temperature. Right? These are your plants. Saturated are your animals. Okay. I could ask, oh, yes, 100% correct. I could ask this, maybe comparing the two. It could honestly be a comparison type of multiple choice type question as well. Or, you know, I give some things that are similar or different, and you got to figure out, you know, which one's correct when it comes to this. So saturated, solid at room temperature, unsaturated, liquid at room temperature. Animal, plant. That's the general gist there. These are your most common, excuse me, these are your most common ones. Again, these are the ones that are on the picture there that we've just been looking at every so often right there. Stearic acids, oleic acids, linoleic, and alpha linolenic acids. These are your kind of most common ones here. As you can kind of see there, I have some monikers in there, and that's in italics. Okay. These are essential. When something's essential, you have to go out and get them in your diet. Your body can't create or make. Okay. Linoleic, alpha linolenic. These are the two acids that are your essential fatty acids. They're 18 carbons in length. Okay. So they can provide a heck of a lot of units of energy. Okay. Where carbohydrates, right, glucose, with metabolism of that, of glucose, it can make 36 just ATP, anywhere between 32 to 36 ATP. Chemistry, it just depends on the cell, okay? But anywhere between that, that's how much energy you get from a glucose molecule, how much ATP. When it comes to an 18 carbon, it can get around like 120 ATP. It's a hell of a lot more than 32 to 36. Okay? So that's why you don't have to consume as much fat to get that ability to make some energy. We have two. Do I have it listed in there? Okay, no. Omega-3, omega-6, omega-9. When it comes to your omegas, those are the three common ones that we have. Of those three, and I don't, yeah, okay, I mentioned a little later. I'll mention omega-9 here just in a little bit. These are your first two right here. These, again, are essential. Essential. I'm pointing at essential. Okay, you can't see me pointing, but I'm pointing at essential. These are essential. Here are my essentials. I don't say, you don't say, oh, well, okay, I need to make sure I get all my alpha linolenic acid and my linoleic acid. You don't say that nonsense. What do we say? We say omega-3 and omega-6. That's how we say it. What in the world is omega-3? It is ALA, alpha linolenic acid. What the heck is omega-6? Linoleic acid. Okay. These are what these are. Omega-6, omega-3. Right. Again, omega-3, it's just the first double bond is at the third carbon. Again, that's how we define what an omega-3 is. That first double bond is at the third carbon. Okay. First double bond is at the third carbon. 1, 2, 3. Okay. So these are essential. Okay. These are our essential fatty acids. These are what you are looking for when you're trying, when you're looking for fish oil pills, right? This is what you're looking at, the content of omega-3 and omega-6s. I have it on the next slide, but I'll just kind of mention it now. Omega-3s and omega-6s are both needed. Omega-3s are going to be more associated with your EPA and DHA. DHA, that probably rings some kind of bell at least. I have all the stuff on the next slide, I believe. Omega-6s are needed as well. There is some debate as to how much you need to consume when it comes to omega-6. Studies are kind of all over the place. But omega-6s are more involved with helping us to make components for the immune response, okay? Inflammatory chemicals, if you will. We eat about roughly 10 times more omega-6s in the American diet than we do omega-3s. So this gives a huge imbalance when it comes to the ratios between 3, 6, and 9 as well. Okay. So if you're consuming more omega-6s that have more pro-inflammatory properties to it, can that create some potential situations for inflammation or a pro-inflammatory state in the body? Potentially. Okay. There's some studies to show this, and there's some studies to show it may not be as severe as what we think it potentially is. So there is that phenomenon. Okay. But omega-3s and omega-6s are a little bit different from that standpoint. Okay, omega-6s are more pro-inflammatory. Omega-3s generally are not. They don't make components that are considered inflammatory, the immune response. So here are what I was just talking about here. Okay, EPA, eicosapentaenoic acid, rolls right off the tongue. Do you have to spell it right? Hell yeah, I'm going to make you spell it right. Docosahexaenoic acid, DHA. I'm not going to be that much of a butthole. Okay, you can just put EPA and DHA on the exam, right? On the exam, I'll probably spell it out and put EPA in parentheses. Same thing for DHA. Okay, I don't expect you to spell it right. Okay. But you should know where EPA and DHA comes from. ALA, which is what? Omega-3. So your omega-3s give rise to EPA and DHA. What do these things do? A ton. Okay. Especially when it comes to brain development. Why is DHA added to everything associated with an infant, a child? Because it's shown to really help bolster brain growth and development. Okay. You need a lot of fats when it comes to brain growth and brain development. Okay. And if you don't consume fats, and if mom doesn't consume fats or a significant amount of fats in her diet, good fats in her diet, that can lead to what's called lissencephaly. It's just a smooth brain. That's all that means. Your brain has all those convolutions in it, all those folds and whatnot. And if you don't consume enough fats when you're pregnant, ladies, this causes the brain not to have all those folds within it, which can lead to some severe, obviously brain development, cognitive development. So fats are really good. DHA is one of those things that are involved with that. Linoleic acid is converted to arachidonic acid. Okay, arachidonic acid, again, omega-6. Omega-6, arachnoids, you get scared. I always associate those with bad. Who likes spiders? No one likes spiders. Professor Lofton likes spiders, okay, but no one else. Well, I'm sure there's some, okay, but I don't. I tolerate them. But arachidonic acid, sorry, squirrel, linoleic acid, okay, more omega-6. Here you can kind of see ALA and EPA and DHA, the derivatives of ALA, are precursors to what are called echinocioids. That's the word I'm looking for. Okay. Echinocioids do a number of different things. It gives rise to a number of hormone-like secretions that the body does, that the body produces. Prostaglandins is probably the biggest one there. As you can kind of see, it does a number of things. It can help to regulate blood pressure. It can help to dampen the immune response. So they can do a bunch of different things. I'm just trying to show you two kind of major ones on both two ends of the spectrum here. Okay? But these echinocioids are hormone-like in nature. Okay. These EPAs and DHAs are precursors to what are called echinocioids. And I think the book goes into it a little bit more in depth, or maybe the previous version. I can't remember. I've been reading two different versions of the textbook, so I'm getting confused in my head. But one of the versions of the textbook goes into it a little bit more, and I'm not going to. This is all I really want you to know. Okay, echinocioids produce precursors to basically what are called hormone-like functions. Okay. In physiology, we go into this process a little bit more because they're vitally important for regulating blood pressure and mediating the huge immune response that we have within our body. And here you can kind of see the lineage that is your PUFAs. And again, PUFAs, why not, right? Omega-3 and omega-6s. Okay, omega-3 gives rise to EPA and DHA, which are going to help with a number of fantastical things. Omega-6 gives rise to arachidonic acid. Arachidonic acid is going to be more pro-inflammatory in nature. It makes the immune response go. So I have omega-3 and omega-6. These are essential fatty acids. All right. If you've ever picked up a bottle of fish oil at a health food store or Hy-Vee or Price Chopper or wherever the heck you get them from, on the label, it'll say omega-3, omega-6, and omega-9. Omega-9 is the other fatty acid. Omega-9 is not essential. Okay? As you can kind of see, it's not a polyunsaturated fat. It's a MUFA. Of course, I had to throw that in. Monounsaturated fatty acid. Right? It is your omega-9, and omega-9 is oleic acid. Okay? As you can kind of see, again, it's not essential. What does that mean? It means the body can make it. That's why we don't ever really get in a huge discussion of omega-9s. It's just omega-3 and omega-6. Those are really the only two. Right? But this is the other fatty acid that we have, oleic acid. And it is slightly less susceptible to spoilage. Omega-3 and omega-6 are pretty susceptible to it, which is why they're in that dark container to help prevent light from getting in there and causing them to be spoiled. But I mean, if you eat an avocado, you've gotten your sufficient amount of omega-3, omega-6, and omega-9. Right? But there's some other sources. If you cook with olive oil, you get it. Right? There is a ratio of omega-3, omega-6, omega-9. And there's a few different websites that get into that. There's a few manufacturers that go into the science behind it as well on their websites. And if you're curious, I can give you that later if you email me and ask. Okay. But omega-3 and omega-6, those are essential. Those are the ones that I'm worried about getting in my diet. I'm not worried about the omega-9. Right? It is not something that I worry about because my body can make it. What's the adequate intake? I struggle because it's something that you should know, but I don't want to get into all the minutia. So I use this instead down here. You can get the adequate intake of your omega-3 and your omega-6s if you just consume 2 to 3 tablespoons of vegetable fat. That's it. Okay. If you eat a serving of fatty fish at least twice a week, you get the your adequate intake for essential fatty acids. Okay. When you're doing this food analysis, your dietary analysis, I always suggest to see, not taking your supplements if you can, okay, if you don't have some weird condition, okay, some non-normal condition, and not take your pills because, if you take a fish oil pill, an omega pill, then you're going to probably get the requisite amount. But see if your diet has it. It's fascinating. Vitamin D is one of those things that is vastly low in a huge number of individuals. Obviously, here during the winter months is when you're going to be most susceptible when we're not outside, not as much sunlight. It gets filtered out by the ozone layers and whatnot. And so we're generally going to be deficient at that time, at least here in the wintertime. And so, taking a vitamin D pill can be helpful and beneficial to boost those levels back up. If you eat real food with a lot of these foods here that have all these fats, avocados, mushrooms, spinach, huge in vitamin D for mushrooms there. If you consume mushrooms once or twice a day, or once or twice or 3 times a week, you get all the vitamin D you need. And it's very easy to be in toxicity-like levels when it comes to fat-soluble vitamins. Well, same thing here with essential fatty acids. If you're somebody who eats salmon twice a week, 3 times a week, once a day, I do right now, I don't need to take my fish oil pill because I'm getting sufficient amounts of my adequate intake for my essential fatty acids. So if that's you, do it with your diet to really see if you need it. More times than not, people don't need to take a lot of their supplementation because their diet supplies it. If you're somebody who works out excessively hard, then you may need the supplementation. You may not. It just depends on your activity level and the type of exercise that you're doing to see if you truly need that multivitamin, multimineral. But this is what I'd like you to know right here. Okay, 2 to 3 tablespoons of vegetable fat, some of those vegetable oils, cooking with those, or eating a fatty fish at least twice a week. Okay, that's what I would like you to know for their AI of essential fatty acids.